In this video, we'll look at how to calculate the distance between a point and a line in 3 space. So we're given a line, and that line is in the form of a vector equation, so r vector equals 115 plus t 1, 8, 7, and then a point 1, 2, 3. We're going to use a distance formula. A distance formula will be given to you on a test. The distance formula we're going to use is the cross product of the direction vector, which I'm going to solve for in a moment, crossed with PQ, and I'll define Q in a moment, all over the magnitude of the D vector. Okay, let's start figuring some of this stuff out. What's this D vector I'm talking about? It's the direction vector of the line. This distance formula uses the direction vector of the line, so let's identify that right here. It's just part of this equation, this vector equation here, and you can read it right there. It's 187. That's D. What's PQ? PQ is going to be the distance from the point that we're given. We're trying to find the distance between a point and a line. We want the distance from this point to some other point on the line. Well, very nicely, we've been given a point here. I'll just put a little arrow to it. That's going to be what we'll use as Q. Here's a point on the line, and here's the point we're looking at the distance from. So we're going to measure the vector PQ by going from our point Q. So we got to go Q is 1, 1, 5, minus our point P, 1, 2, 3, and we get the point 1 take away 1 is 0, 1 take away 2 is -1, and 5 take away 3 is 2. So we've got our vector PQ from the point to point, one off the line, and one on the line. That's going to be our vector, and we use this formula. We'll find the cross product now. We got to do the D vector, this direction vector of the line, crossed with PQ. Alright, well here's our D, here's our PQ, so let's write out the D vector, 187, 187, that's a little close together. And then we'll write out our PQ vector, 0, -1, 2, 0, -1, 2, and we'll use our strategy. I recommend the video on cross product. If you're not sure what's happening here, please watch that video. And so on the side here, I'm going to calculate D vector crossed with PQ vector. Right now I'm just figuring out what that vector is, not its magnitude yet. So cross product is this, take away this, so 16, better put a bracket here, 16 minus 7, 16 plus 7, and then 0 times 7 minus 2, so it's 0 minus 2, and then 1 times -1, that's -1, minus 8 times 0, which is -0. And so what do I get? 23, -2, and -1. Got my cross product there. But remember, the formula doesn't use cross products vector magnitude. It doesn't use the vector, it uses the magnitude. So now I want to show, okay, I'm calculating the magnitude now of that cross product I just found. Well, the magnitude is just the square root of the components. So that's the square root of 23 squared plus -2 squared plus -1 squared. And what does that equal? You can use your calculator. I'm probably going to leave it as a radical. It's 23 squared plus 2 squared is 4 plus 1. And you get a total of 534. Remember, it's still inside a square root. So the magnitude of that cross product that I just solved is the square root of 534. Great. And now I need to calculate the bottom of this distance formula that you'll be given. The bottom is calculate the magnitude of the D vector. So what's my D vector? 187. So its magnitude is just the square root of its components. So 1 squared plus 8 squared plus 7 squared, which equals, I could probably do most of that in my head. 1 squared, that's obviously 1. 8 squared, 64. 7 squared, 49. And you get 114. So that's the square root of 534 over the square root of 114. And normally it can leave things in radical form, but usually we don't leave things as a radical over a radical. You could try and reduce those radicals to lowest form by seeing what goes in and splitting them up, but I think I'm just going to make it a decimal. After all, we're interested in distance. We're often interested in a decimal. So what's the square root of 534 divided by the square root of 114? You get approximately, need a rounding dot, 2.16. So there we go. If you wanted to, you could have reduced the radicals, but I chose to make it a decimal, and I'll accept that on a test. And we're done. We found the distance between a point and a line in 3 space. How'd we do it? We looked at the line's equation to get its direction vector, and we used a point on the line and a point that we were given, that's what we're finding the distance to make the PQ vector, which is part of our formula. You take that PQ vector and do the cross product of it with the direction vector. The direction vector has to come first. And we get our direction vector's value, which was 23, -2, -1. We found its magnitude, and we found the direction vector's magnitude, plugged it back in the formula, and solved.